Beneath the endless white, where silence reigns and the wind carves secrets into frozen plains, lies a world untouched by time. A place where trees once whispered, rivers once sang, and life flourished in a forgotten forest now buried beneath miles of ice. What stories do these silent giants hold? What echoes of ancient earth are trapped, preserved in crystalline tombs? Today, we descend into the frozen veil of Antarctica to uncover the fossil forests that have lain hidden for millions of years, frozen yet unyielding, waiting for the light of discovery. Take a moment, subscribe, and join this journey to the edge of the world, where the past sleeps beneath a white desert, waiting to speak. The moment you set foot on Antarctica, the world as you know it seems to vanish. The sky stretches endlessly, a pale, icy dome above a landscape that is both alien and astonishingly familiar. Here, silence is not the absence of sound, but a presence itself dense, heavy, and all-encompassing. Each gust of wind sculpts the snow into endless ridges and hollow valleys, a frozen symphony played on the instruments of ice and rock. You can feel the weight of time pressing down, a reminder that this is a land where human footprints are fleeting, almost insignificant, against the vast theater of millennia. Beneath the white expanse lie secrets so ancient, they challenge the imagination. Entire forests, once alive and vibrant, now preserved under kilometers of ice, waiting for the patient eyes of those willing to seek them out. Antarctica is not merely cold. It is a force that shapes everything it touches. Temperatures plummet to extremes that feel almost unimaginable, yet life, in small, tenacious forms, endures at the edges. Lichens cling to the bare rock, microbial mats thrive in subglacial lakes, and seals drift through waters that seem hostile, yet are pulsing with hidden energy. The ice itself is a storyteller. Each layer is a page in a diary of the planet, recording millennia of storms, volcanic eruptions, and climate shifts. The ice creaks and groans as if speaking in a language older than any human tongue, revealing the slow, inexorable pulse of a continent that has witnessed the rise and fall of entire ecosystems. As you gaze across the endless plains, you realize that Antarctica is a paradox. It is at once desolate and teeming with history, barren yet full of life's silent traces. Mountains pierce the horizon like frozen sentinels, their jagged peaks dusted with snow, casting long shadows across valleys that have never known human interference. Glacial rivers wind beneath the ice, unseen yet vital, carving paths that have endured for millions of years. Here, time does not rush, it coils and stretches, folding epochs into single, crystalline moments. It is a land that demands patience, reverence, and awe. Every step, every inhalation of frigid air, is a communion with a past far older than the cities and civilizations we take for granted. But beneath this surface of endless white, another world exists, an ancient forest frozen in amber like ice, its trees and undergrowth preserved as if time had chosen to pause. These forests are remnants of a world that defies imagination. Ferns unfurling, conifers standing tall, mosses carpeting the ground. How did such life thrive where now only ice reigns? The answer lies in the continent's slow drift across the planet, its transformation from a lush, temperate wilderness into a frozen desert. The fossilized remains whisper of climates warmer than today, of rainfall nurturing green canopies, of creatures that lived and died long before humans etched their stories into the world. Every branch and every trunk trapped beneath the ice is a memory, a fragment of Earth's deep past waiting to be understood. In this chapter of discovery, we begin with the continent itself. Its vastness is almost incomprehensible, a white desert that stretches for millions of square kilometers, punctuated by mountains, ice shelves, and hidden lakes. The wind is a sculptor, shaping drifts and dunes, while the ice below shifts imperceptibly, grinding rock into powder, carving valleys, and revealing the occasional glimmer of fossilized life. Here, the human spirit feels both diminutive and elevated. Dwarfed by scale, yet inspired by the sheer persistence of life against adversity. To understand Antarctica is to understand patience, endurance, and the quiet grandeur of a world untouched by modernity. And yet, as the sun arcs low across the horizon, painting the ice in fleeting golds and blues, one cannot help but wonder what lies beneath. What stories are trapped in the ice, waiting to speak? Which forests, which creatures, which lives have been preserved by this frozen cradle? As explorers and scientists venture into this realm, each step is both literal and symbolic, a journey into the unknown, a communion with history, and a confrontation with the sublime. Antarctica, the silent continent, is not merely a place. It is an experience, a living narrative etched in frost, waiting for those willing to listen. As the horizon stretches endlessly, one begins to grasp the staggering scale of Antarctica's isolation. There are no roads, no cities, no whisper of civilization, only the raw, sculpted terrain of ice and rock, a continent that exists on its own terms. The silence here is punctuated only by the occasional fracture of a distant glacier, a sound so deep and resonant it feels almost subterranean, as if the planet itself were exhaling. It is a reminder that Antarctica is alive, though its life operates on timescales far beyond human comprehension. Ice shifts imperceptibly, mountains erode, and yet beneath the frozen crust, remnants of a green, thriving world endure. Fossil forests, hidden for millions of years, lie preserved as fragile echoes of an epoch when warmth and life stretched across the very ground now cloaked in frost. Every crevice, every ridge, carries a story of transformation. Millions of years ago, this land was vibrant, teeming with flora and fauna unimaginable under today's frozen expanse. Conifers, ferns, and flowering plants painted the landscape in shades of green, their roots drawing sustenance from rich volcanic soils. Rivers carved the valleys, and the wind carried the scent of life rather than the metallic tang of ice. To step onto Antarctica now is to step into a memory, a landscape layered with time, where the present and the distant past collide in quiet, dramatic tension. Fossils trapped beneath the ice are more than mere remnants. They are messages from a world that once existed, preserved with painstaking fidelity by the relentless embrace of frost. The ice itself acts as both guardian and storyteller. Layers upon layers of snow, compressed over millennia, hold within them fragments of atmosphere, traces of volcanic eruptions, and even microscopic remnants of the forests that once stood here. Each drill core extracted by researchers is a vertical voyage through time, revealing chapters of Earth's climate and the slow, inevitable march toward the Ice Age. The deeper one delves, the older the story becomes, until the surface of the world as we know it fades into obscurity and we confront a landscape utterly alien in its frozen grandeur. It is both humbling and exhilarating to witness a continent where time has been preserved in crystal and life's fragility is highlighted against the permanence of ice. Explorers who venture into this stark wilderness quickly learn that survival is a delicate negotiation. Temperatures can plummet without warning, storms rage with relentless ferocity, and the terrain itself conspires against the unwary. Yet it is this very hostility that has preserved the continent's secrets. Unlike other lands, where forests fall to fire, disease, or human interference, Antarctica's fossilized forests remain untouched, ensconced beneath layers of ice and rock. In their stillness, they become mirrors of an Earth that was once lush and alive, offering a vision of life adapted to warmth, humidity, and movement, now frozen in an eternal moment of quietude. Each tree, each fern, each spore encapsulated beneath the ice is a relic of resilience, a whisper from a world long past, waiting to tell its story. Walking across the icy plains, one cannot help but feel a strange intimacy with the continent's history. Footsteps sink into snow that has barely shifted for centuries, and the wind carries the faint, almost imperceptible sense of the forests beneath. There is an eerie poetry in this interplay of absence and presence, of destruction and preservation. For the scientist, the historian, or the wanderer, Antarctica is a classroom without walls, a museum without glass, where the exhibits are buried, waiting for patient hands to uncover them. It teaches lessons of endurance, adaptation, and the delicate balance between life and environment, while simultaneously evoking awe at the sheer magnitude of nature's forces. And so, as the sun drifts toward the horizon, casting long shadows across ice-clad mountains and shimmering plains, one senses the silent pulse of this continent. Beneath the surface lies a hidden vitality, frozen yet vivid, delicate yet enduring. Antarctica is more than a frozen wilderness. It is a repository of Earth's ancient memory, a cathedral of frost where life's echoes endure in crystalline form. Each step into its heart is a step into a story older than human history, a narrative written not with ink but with ice, snow, and stone. Here, the silent continent reveals itself slowly, insistently, as though inviting those willing to listen to witness its secrets, to feel its stories, and to understand the profound quiet power of time preserved beneath the white expanse. The vastness of Antarctica is something that defies ordinary comprehension. As you move across its frozen plains, the scale of the continent reveals itself in a slow, almost imperceptible crescendo. Snow stretches in all directions, unbroken, until it meets jagged peaks that rise like the spines of some ancient, slumbering beast. The horizon itself seems to curve, an illusion born of distance and light, while the wind sculpts the landscape with tireless precision. Here, human presence is ephemeral, a fleeting disturbance on a stage that has endured for millions of years. And yet, beneath the frozen surface, life's history lies in suspended animation, preserved with meticulous fidelity. Fossil forests, once lush and green, now lie entombed beneath ice that has grown layer by layer over epochs, a monument to time and transformation. Imagine standing on the edge of a glacial plateau, feeling the sting of the wind as it cuts through every layer of clothing, and knowing that beneath your feet lie remnants of a world long vanished. Trees that once reached toward a warm sky, ferns that carpeted the ground in vibrant greens, cycads that swayed in temperate breezes, all of them are trapped beneath kilometers of ice, invisible to the eye, yet immaculately preserved. This is Antarctica's paradox, a land devoid of life in the present, yet brimming with traces of its once thriving ecosystems. Every fossilized fragment, every imprint in stone or ice, is a message from an epoch when the continent's story was dramatically different. What does it mean to witness such time? To stand above a world that existed millions of years ago, frozen yet preserved, tangible yet unreachable? It is a confrontation with both the fragility and resilience of life itself. The ice is not merely a covering, it is an archive. Scientists call it a natural library, where each layer of snow and frost is a page recording storms, volcanic eruptions, and the atmospheric conditions of the distant past. As they drill into the ice, extracting cores that extend hundreds of meters below the surface, researchers are not just uncovering frozen water, they are unlocking secrets of climate shifts, of environmental cataclysms and recoveries, of the delicate interplay between flora, fauna, and climate. Within these cores lie traces of the fossil forest themselves, pollen grains, wood fragments, spores, microscopic witnesses to a world long gone. Each sample is a puzzle piece, a fragment of a narrative that tells how a verdant paradise became a frozen desert. And each discovery resonates with a quiet poetry, for in these fragments lies the memory of life persisting against the relentless passage of time. Walking through the barren plains, one cannot help but feel the weight of history. Antarctica is a continent that enforces reflection. The wind whistles through crevices, carrying whispers of eons past, and the ice beneath your feet seems to thrum with a rhythm older than human imagination. Every step is a dialogue with time, an acknowledgement of a continuum that stretches beyond comprehension. The mountains that punctuate the icy expanse are not merely geological formations. They are sentinels of memory, guardians of stories that predate humanity, holding within their frozen grasp the echoes of rivers, forests, and skies that once shimmered with life. Here, the observer becomes acutely aware of scale, the minuteness of human existence contrasted against the immensity of the planet's history. Yet, the silence of Antarctica is not empty. It is a voice, subtle and persistent, that demands attention and respect. Crevasses open without warning, exposing the raw beauty and peril of the continent's underbelly. Glacial calvings shatter the stillness with a thunderous crash, a reminder that this is a living world, constantly in motion, even when change appears imperceptible. And beneath it all, the fossilized forests endure, unseen but undeniable. They are frozen archives of life that thrived under conditions unimaginable to the modern human mind, a world warmed by greenhouse climates, nourished by rainfall, and animated by the hum of ecosystems now vanished. To contemplate these forests is to confront the temporal fragility of existence, the impermanence of landscapes, and the astonishing power of preservation through ice. Antarctica is also a land of extremes, where light itself behaves strangely. During summer months, the sun arcs in an endless circle above the horizon, casting shadows that stretch for miles and illuminating the ice in blinding brilliance. In winter, darkness reigns, and the landscape becomes a monochromatic dream, where stars seem closer and the aurora dances across the sky, painting it with colors that defy earthly palettes. These light cycles transform the continent into a stage of perpetual drama, underscoring the narrative of survival, endurance, and revelation. In such conditions, the fossil forests are more than relics. They are symbols of life's capacity to persist, to adapt, and ultimately to leave traces for those patient enough to discover them. Every expedition to this frozen land is both a physical and emotional journey. Scientists, explorers, and dreamers alike navigate crevasses, cross icy plains, and endure sub-zero temperatures, drawn by the allure of Antarctica's hidden history. They are guided by intuition, by maps, by satellite imagery, and by a deep, almost spiritual curiosity. And when they encounter a fragment of fossilized wood, or a layer of ancient soil preserved under ice, it is as if time itself has paused, allowing them a glimpse into a world long vanished. These discoveries are moments of awe, blending the scientific with the poetic, the analytical with the emotional, and creating a profound sense of connection between humanity and Earth's distant past. And so, as the sun dips toward the horizon, scattering shades of gold and crimson across the ice, Antarctica asserts its presence as the silent continent. It is a place where time folds upon itself, where the past and present coexist in frozen tension, and where the echoes of life endure beneath a white veil. To witness this land is to feel the weight of millennia, to sense the persistence of life in forms both visible and hidden, and to confront the breathtaking scale of a world untouched by human hands. Every gust of wind, every shadow cast across the ice, every fracture in a glacier is part of a living narrative, one that invites us to listen, to observe, and to honor the fragile yet enduring story of a continent that guards the memories of forests beneath the ice. Beneath the blinding glare of Antarctica's sun, the landscape appears eternal, unchanging. Yet every footstep reveals that beneath the frozen surface, the world is alive with memory. The ice is not inert. It shifts, grinds, and creaks, whispering the story of eons. Each crevasse is a scar of time, each ridge a record of movement and pressure, and each glacial river, hidden beneath thick layers of frost, carries water that has never touched the sky above. It is a continent that exists on its own terms, indifferent to human presence, yet intimately connected to the cycles of life and death that shaped the planet long before our species walked the earth, To enter this realm is to confront the sublime, a landscape at once brutal and beautiful, where silence carries the weight of history, and every frozen fragment holds the potential to reveal the past. In the hidden valleys beneath the ice, fossil forests lie in patient repose. These are not mere remnants. They are time capsules, preserving the vibrancy of ecosystems that flourished millions of years ago. Imagine trees taller than modern conifers, ferns unfurling in warm, humid sunlight, and mosses carpeting the soil in an endless green tapestry. These forests were not isolated pockets. They were thriving ecosystems, teeming with life, shaped by rivers, rainfall, and the gentle rhythm of the seasons. Today, they exist only in fragments trapped under ice, fossilized in wood, leaves, and spores. Yet their preservation is a marvel, a testament to the remarkable capacity of the natural world to protect memory even as it transforms. Each fossil tells a story of growth, struggle, and survival, offering a window into climates, landscapes, and life forms that have been erased from the surface but remain alive in the geological record. As scientists traverse the frozen plains, they carry with them not only tools of research, but also reverence for the fragile legacy beneath their feet. Every drill into the ice, every careful excavation, is an act of dialogue with a world long gone. The process is painstaking. Ice cores are extracted with precision, sediment layers analyzed for fossilized pollen and wood fragments, and each finding meticulously cataloged. The work requires patience, resilience, and a willingness to confront extreme conditions. Yet, the rewards are profound. To uncover even the smallest fragment of a fossilized tree is to touch history, to connect with a continent that once harbored forests, rivers, and life in ways unimaginable beneath its current frozen veneer. These discoveries are moments of awe, merging the scientific and the poetic, revealing not just facts but stories, not just data but echoes of a world preserved in crystal. Antarctica's climate itself is a storyteller, inscribed in ice and stone. Layers upon layers of frozen precipitation hold the memory of ancient storms, volcanic eruptions, and the slow drift of continents. Through meticulous study, scientists reconstruct epochs of warmth and cooling, of greenhouse climates and ice ages, piecing together the narrative of a land transformed. Fossil forests are central to this understanding. Their preserved remains provide tangible evidence of the continent's once lush environment, revealing cycles of growth and decay, survival and adaptation that parallel the patterns we observe in modern ecosystems. To study these forests is to read the continent as a manuscript, where every line etched in ice tells of change, resilience, and the inexorable passage of time. Yet there is an emotional weight to this knowledge. To witness a fossilized forest beneath the ice is to confront mortality on a geological scale. The trees that once thrived here now exist only in fragments, preserved as silent witnesses to a world that has vanished. Their story is not one of sudden destruction, but of transformation, a reminder that life is both fragile and enduring. It invites reflection on the forces that shape our planet, on the impermanence of landscapes, and on the responsibility of humans to understand and preserve the history that remains. Antarctica, in this sense, is not only a site of scientific inquiry, it is a place of meditation, a cathedral of memory where the echoes of forests speak across millions of years. As the day wanes and shadows stretch long across the ice, the scale of the continent becomes ever more apparent. Mountains rise like frozen monuments, glaciers carve paths that span kilometers, and the wind sculpts snowdrifts that ripple like waves across a frozen sea. Each element of the landscape contributes to the story of survival and preservation, shaping both the physical world and the memory it holds. And beneath it all, the fossil forests endure, hidden but potent, a reminder that life's legacy can outlast even the harshest of climates. To observe this interplay of forces, the relentless pressure of ice, the enduring persistence of life, and the stark beauty of a frozen horizon, is to grasp the silent majesty of a continent that has witnessed more than any human eye can imagine. In this chapter, the focus remains on the continent itself, its scale, its isolation, and the stories it holds beneath the ice. Every crevice, every ridge, every layer of frost contributes to a narrative of endurance, adaptation, and preservation. Antarctica is a land where human time is insignificant, yet it is precisely this insignificance that allows us to perceive the grandeur of life's persistence. The fossil forests are not just scientific curiosities. They are monuments to existence itself, frozen in the medium that both conceals and protects. They remind us that even in the most extreme and inhospitable conditions, the traces of life endure, waiting for those willing to uncover them, study them, and honor the depth of their history. And so, as the sun dips below the horizon, casting the ice in shades of violet and gold, one feels the full weight of Antarctica's silence. It is a silence that speaks, a quiet grandeur that humbles and inspires. Beneath the blinding white, hidden forests await their discovery, silent yet eloquent, preserved in ice that has outlasted millennia. Antarctica is not merely a frozen desert. It is a living archive, a testament to the resilience of life and the unyielding passage of time. To walk across its plains, to stand on its peaks, to listen to its winds, is to bear witness to a story written in ice, a story of survival, transformation, and the enduring power of memory preserved beneath the white expanse. As darkness slowly encroaches on the ice-clad plains, Antarctica reveals a different aspect of its majesty. The sun's pale light retreats and long shadows stretch across the frozen ridges, turning the landscape into a chiaroscuro of subtle blues, silvers, and grays. The wind, ever present, carries with it a hush that feels almost sacred, as if the continent itself demands silence in the presence of its ancient memories. Every crunch of snow beneath boots, every crack in distant ice, echoes with history. Here, one begins to sense that Antarctica is more than a landmass. It is a chronicle, an archive, a cathedral of time where the ghosts of past life linger quietly beneath layers of frost, waiting for discovery. Beneath the surface, the fossil forests lie untouched, as though sleeping under a crystalline veil. Imagine the scene. Towering conifers that once reached for a warm sky, ferns spreading across the forest floor in verdant abundance, cycads that flourished in humid microclimates, all preserved in delicate detail. Their existence now a silent testament to a warmer, thriving Earth. The ice, in its slow, imperceptible movement, has safeguarded them for millions of years, transforming what might have been decay into eternal preservation. Each fragment of fossilized wood, each petrified leaf, is a frozen story, a page from a book written in an epoch before the human gaze could comprehend it. To encounter these remains is to touch the pulse of time, to feel intimately connected to a world that existed long before cities and civilizations rose and fell. The process of uncovering these hidden forests is an act of reverence. Scientists and explorers work with meticulous care, aware that each fossil is a fragile bridge between past and present. Ice cores are extracted with painstaking precision, and sediment layers analyzed for traces of pollen, spores, and ancient plant material. Each sample recovered is a revelation, a piece of a landscape lost to time, preserved beneath layers of frost that are as protective as they are forbidding. As researchers handle these remnants, a sense of awe permeates the work, for it is not merely science, it is communion with history, a chance to witness the endurance of life against the unyielding passage of millennia. Antarctica's extreme climate amplifies the drama of discovery. Temperatures plunge to levels that seem uninhabitable. Storms sweep across the plains with relentless ferocity, and crevasses yawn like slumbering predators. Yet, it is precisely these harsh conditions that have safeguarded the continent's fossilized legacy. Unlike forests elsewhere, destroyed by fire, disease, or human intervention, Antarctica's ancient ecosystems remain undisturbed, frozen in time. Every discovery becomes a narrative thread connecting the present to a distant past, revealing the transformations that reshaped a once lush continent into a frozen desert. The fossil forests are living lessons, teaching patience, resilience, and the intimate interplay between life and the forces of nature. There is also a philosophical dimension to these discoveries. Antarctica forces reflection not only on the natural world, but on human existence within it. Standing on a windswept plateau, looking down into the icy expanse, one feels both infinitesimal and connected to the vast sweep of time. The continent's silence is not empty. It speaks of endurance, of survival, and of the transient yet recurring cycles of life. Fossil forests are more than relics. They are reminders that life persists, adapts, and leaves traces long after the conditions that nurtured it have vanished. They speak to the resilience of nature, the inevitability of change, and the enduring beauty of a world that operates beyond human comprehension. As night settles, the icy plains take on an ethereal glow, lit faintly by the lingering shimmer of the sun below the horizon or by distant auroras dancing across the sky. The landscape becomes almost otherworldly, as if it exists in a liminal space between time and eternity. Every feature, the mountains, the glaciers, the frozen rivers, is heightened in drama, underscoring the narrative of endurance and preservation that runs beneath the surface. And beneath all of this, the fossil forests lie in silent anticipation, waiting for the curious, the patient, and the persistent to reveal their stories. In these moments, Antarctica transforms from a frozen wasteland into a living memory, a repository of life's triumphs and vulnerabilities, and a testament to the extraordinary capacity of the planet to conserve its history. In contemplating the silent continent, one is struck by its paradox. It is a place of absence and presence, of desolation and vitality. The ice covers, yet it protects. The wind howls, yet it carries whispers of ancient forests. The landscape appears static, yet it is alive with memory and movement. Every crevasse, every ridge, every buried tree contributes to a narrative that spans millions of years. It is a story not only of Antarctica's transformation from green paradise to icy expanse, but also of life's enduring capacity to leave traces across time, a narrative waiting for human curiosity to uncover it. And so, as the night deepens and stars glimmer over the frozen horizon, Antarctica stands as both monument and mystery. Its silent forests, preserved beneath layers of ice, are more than scientific curiosities. They are connections to a world that existed long before human history, reminders of a planet that has weathered unimaginable change. Each fossilized tree, each trace of life, is a message from the deep past, waiting to be heard, studied, and honored. To walk across these frozen plains is to step into a story far larger than oneself, to confront the grandeur and fragility of life, and to bear witness to the enduring legacy of the silent continent. As dawn will rise again, painting the ice with fleeting colors of gold and rose, one realizes that Antarctica's story is only beginning to be told. The frozen forests beneath the ice whisper patiently, inviting exploration, understanding, and reverence. And in listening to these whispers, we come closer to understanding not just the past on a frozen continent, but the enduring narrative of life itself, its triumphs, its losses, and its capacity to persist against all odds. Antarctica is not merely a place on a map. It is a living chronicle, a silent continent that teaches us the profound patience and respect required to comprehend the depth of time preserved beneath its wide expanse. Beneath the white silence of Antarctica lies a secret world that defies imagination. A world where sunlight once filtered through towering canopies, where leaves rustled in warm breezes, and where life flourished in ways impossible to reconcile with the continent's current frozen visage. Imagine a place of lush greenery, rivers winding through valleys, and forests so dense that their shadows stretched like living blankets across the fertile soil. These are not figments of a fanciful past. They are the fossilized remains of an epoch when Antarctica was a vibrant, thriving landscape, a world far removed from the ice deserts we now traverse. To step into this memory is to confront both wonder and melancholy, for these forests are preserved beneath miles of ice, silent witnesses to the dramatic transformations that have reshaped the planet over millions of years. The first glimpses of these ancient forests come not from sight, but from fragments, a piece of fossilized wood, a petrified leaf, spores trapped in sediment. Yet even these small remnants speak volumes. Each tree trunk tells a story of growth in warmth and moisture, of branching structures that once competed for sunlight, of roots that dug deep into soils long since buried beneath ice. Ferns, cycads, and conifers flourished here, forming ecosystems that rivaled the richness of modern temperate forests. Rivers nourished the ground, winds carried pollen across valleys, and the air thrummed with the energy of life. To hold a fragment of these trees is to feel the pulse of a world that existed millions of years before the first humans walked the earth, a world of vibrancy and resilience, now suspended beneath a frozen shroud. Antarctica's fossil forests are preserved with a precision that borders on miraculous. Layers of ice and sediment have acted as both guardian and archive, halting decomposition and shielding the remnants from erosion. Petrification, mineral replacement, and compression have transformed once living material into enduring records of life's form and structure. Tree rings, leaf patterns, and vascular structures are all discernible, offering scientists a window into ancient climates, seasonal cycles, and environmental stresses. Each fossil is a narrative frozen in time, a story of life's adaptation to conditions that, while unfamiliar today, were once nurturing and abundant. Through careful study, these fossils reveal the richness of Antarctica's pre-glacial ecosystems and hint at the climatic and tectonic events that would eventually cloak the continent in ice. To visualize these forests is to see a world of contrast. Towering conifers interspersed with low-lying ferns, mosses carpeting the ground in vivid green, and a network of rivers and lakes glinting in sunlight that once bathed the landscape in warmth. Prehistoric Antarctica was a place of dramatic beauty and ecological complexity, supporting a diversity of plant life that thrived under conditions far warmer than those of the present day. The fossil record captures this detail with astonishing clarity, allowing researchers to reconstruct the dimensions, density, and species composition of forests that existed tens of millions of years ago. What is remarkable is not only the survival of these fossils, but the clarity with which they convey life's intricate dance, the interplay of growth, competition, and survival across epochs. The fossil forests also tell a story of transformation. Antarctica's drift from equatorial latitudes to its current polar position, coupled with global climate cooling, gradually reshaped these landscapes. Forests that once flourished under humid, temperate conditions were slowly overtaken by changing temperatures and the encroachment of ice. Rivers dried or froze, soils altered, and plant life adapted, migrated, or perished. Fossilized remnants capture these shifts, preserving evidence of resilience, adaptation, and loss. Each petrified tree, each preserved leaf, is a testament not just to survival, but to the inevitability of change, illustrating how ecosystems respond to environmental pressures over geological time. Field expeditions to uncover these hidden forests are journeys into both space and time. Researchers navigate glaciers, crevasses, and sub-zero temperatures to access sites where fossils lie buried. Using ice cores, remote sensing, and meticulous excavation, they peel back layers of ice and sediment to reveal fragments of a prehistoric world. The process is painstaking, yet the rewards are profound. When a fossilized tree emerges from its icy prison, it is not simply an artifact, it is a conversation with the past. The shapes of the branches, the textures of the bark, and the patterns of leaves speak across millions of years, connecting the present observer with life that once thrived in an environment unimaginable today. Beyond scientific curiosity, these forests evoke emotional resonance. Standing over a fossilized grove, one can imagine the wind rustling through the branches, the smell of rich soil and vegetation, and the subtle hum of life that once filled the valleys. There is a haunting quality to this encounter, a mixture of awe and melancholy, because the forests exist now only in memory, preserved beneath ice. Yet their preservation also inspires wonder, a testament to the power of natural processes to both protect and reveal. In this way, Antarctica's fossil forests become more than relics. They are storytellers, teachers, and reminders of the planet's capacity for both creation and endurance. As we continue our journey into these frozen archives, it becomes clear that the forests beneath the ice are keys to understanding Antarctica's past. They provide insight into climate shifts, ecological dynamics, and the interplay between land, life, and atmosphere. By studying the growth rings of trees, the distribution of leaf fossils, and the sedimentary context of each find, scientists reconstruct the ancient landscapes with astonishing fidelity. Every fossil contributes to a mosaic of life, illustrating how ecosystems evolve, collapse, and sometimes endure, even under extreme conditions. Through this lens, Antarctica transforms from a frozen wasteland into a living memory, a repository of ecological knowledge waiting for patient observers to uncover and interpret. And so, the forests beneath the ice invite us to imagine a world transformed, a land of sunlight, greenery, and life, now cloaked in white and silence. They challenge our perception of Antarctica as barren and lifeless, revealing it instead as a dynamic archive of Earth's ecological history. To step into this narrative is to step into the pulse of a continent that has endured unimaginable change, preserving life in forms both visible and hidden. These fossil forests are more than scientific curiosities. They are enduring reminders that even beneath ice, life's traces can persist, waiting to speak to those willing to listen, study, and honor the memory of a world that existed long before ours. Beneath the frozen surface, the fossilized forests reveal details that are almost impossible to imagine without seeing them. Trees that once towered like green sentinels now lie perfectly preserved in stone and ice, their textures, knots, and growth rings intact. The patterns of their life, years of growth, periods of drought, seasons of abundance, are all written into the wood, as precise and deliberate as a journal left by nature itself. By examining these rings, scientists can decipher cycles of climate change that predate human records, uncovering patterns of warmth, rainfall, and extreme weather that shaped entire ecosystems. Each trunk, each branch, each fragment of preserved bark is a piece of the puzzle, a message from a world that was alive, verdant, and dynamic long before Antarctica became a white desert. The fossil forests speak not only to the past, but also to the vast transformations the continent has undergone. Imagine ferns unfurling beneath the canopy, mosses carpeting the forest floor, and conifers competing for sunlight in dense groves. This was a land of abundance, of life flourishing under humid, temperate conditions. Yet, as tectonic shifts repositioned Antarctica toward the poles, and as global climates cooled, these once thriving forests face relentless environmental change. The encroachment of ice, the decline of rainfall, and the shortening of growing seasons created pressures that eventually forced these ecosystems into preservation beneath layers of frost. What remains today are not mere fossils. They are testimonies to endurance, resilience, and the unstoppable forces of nature that sculpt the planet over millions of years. Scientists who explore these frozen archives must confront both the physical extremes and the conceptual vastness of their task. Accessing the fossil forests is no simple feat. Teams traverse treacherous ice fields, navigate hidden crevasses, and endure temperatures that would be fatal to the unprepared. They employ drills, ice augers, and remote sensing equipment to locate pockets of fossilized vegetation, carefully extracting cores without damaging the delicate specimens. Each find is meticulously cataloged, photographed, and analyzed, revealing minute details about the size, structure, and species of the plants that once flourished here. The work demands patience, precision, and a reverence for the fragile history that lies beneath the ice. For in each fragment lies a record of life that has survived where few others could. The process of uncovering these forests is also a deeply poetic experience. Imagine standing on the edge of a glacier, staring down at a layer of ice and sediment that has preserved life for tens of millions of years. To remove a piece of fossilized bark is to reach across time, to connect with a world that no longer exists in its original form. The textures of the wood, the curves of leaves, and the patterns of growth rings tell stories of seasons, storms, and survival. Every detail contributes to a larger narrative of life adapting, enduring, and ultimately leaving traces for future observers. In this way, Antarctica's fossil forests are not simply objects of study. They are storytellers, narrating the planet's history with a quiet eloquence that demands attention, respect, and wonder. The richness of these forests also extends to their ecological complexity. Fossil evidence reveals that Antarctica was not a uniform landscape, but a mosaic of habitats. From dense groves to open glades, from riverside floodplains to higher ridges with different microclimates. Trees of different species coexisted, competing and collaborating in subtle ways, while ferns and mosses created undergrowths that supported countless forms of life. The interplay of light, water, and soil created a vibrant system of energy flow, with each organism contributing to the web of life. Even as these ecosystems fell silent beneath the advancing ice, the complexity of their structure remains encoded in the fossil record, providing modern science with insights into the resilience and adaptability of life in the face of profound environmental change. Studying these ancient forests also illuminates the broader narrative of Earth's climate history. Fossilized pollen, spores, and plant fragments provide critical data about the atmosphere, temperature, and precipitation of the past. By analyzing these clues, scientists can reconstruct cycles of warming and cooling, shifts in greenhouse gas levels, and the impact of tectonic movement on continental climates. Antarctica, in this sense, is not just a frozen wasteland, it is a laboratory, a living archive of global climate history, offering lessons that extend far beyond its icy borders. The fossil forests serve as both evidence and warning, illustrating the delicate balance of ecosystems and the dramatic consequences when that balance is disrupted. There is an undeniable sense of awe in standing before a fossilized forest. The mind struggles to reconcile the vivid life that once existed here with the stark whiteness that now dominates the landscape. One can almost imagine sunlight filtering through the canopy, the rustling of leaves in warm wind, and the quiet hum of insects and birds long extinct. The contrast between past and present is profound. A lush, green world transformed into an ice desert, yet preserved so perfectly that life's echoes remain tangible. The experience is at once humbling and inspiring, a reminder of the persistence of nature and the fragile beauty of the ecosystems that sustain it. In contemplating the forests beneath the ice, one also confronts the impermanence of life. These trees, once thriving and dominant, are now reduced to fragments, preserved only by the extraordinary conditions that encase them. Yet in their preservation, they achieve a form of immortality, speaking to generations of scientists and explorers who will continue to uncover their secrets. They remind us that life leaves traces, that ecosystems, no matter how complex or resilient, are vulnerable to change, and that understanding the past is essential for safeguarding the future. Antarctica's fossil forests are a bridge across time, connecting us to a world both alien and familiar, frozen yet alive in memory. As night falls on the icy plains and the aurora paints the sky with spectral ribbons of green and purple, the fossil forest beneath Antarctica remains silent yet eloquent. They have survived tectonic shifts, climate upheavals, and the inexorable advance of ice. They offer a story of endurance and transformation, a narrative that demands attention and contemplation. To witness them is to witness time itself layered, preserved, and patiently waiting for those who seek to understand the profound mysteries of life's resilience. Antarctica's forests beneath the ice are not just fossils. They are the whispers of a forgotten world, a testament to the extraordinary capacity of life to persist, and a reminder that even in the harshest conditions, memory endures. The deeper one explores Antarctica, the more the fossil forests reveal their hidden intricacy. Beneath the white expanse, preserved in ice and sediment, lie entire ecosystems, frozen in a state of suspended animation. Every petrified trunk, every fossilized leaf, every trace of ancient undergrowth speaks not only of life, but of interaction, adaptation, and survival. These forests were not static. They thrived, competed, and evolved over millions of years, responding to changes in climate, volcanic activity, and shifting landscapes. Fossilized conifers towered beside delicate ferns. Cycads spread across fertile soils, and rivers meandered through valleys, nourishing the soil and sustaining life. The fossil record captures these details with breathtaking fidelity, revealing a world of complexity and vitality now hidden beneath a frozen blanket. Walking through these discoveries, researchers are confronted by the sheer scale of time. Fossilized trees tell stories that far exceed human lifespans, spanning centuries of growth and cycles of seasons. Rings in the wood, patterns in the bark, and imprints of leaves record not only the life of the trees themselves, but the broader environment in which they lived. Each fragment of plant material is a clue, a record of rainfall, temperature, and ecological dynamics from an era when Antarctica's climate was temperate and lush. The richness of the fossilized ecosystems defies expectation, challenging assumptions that this continent has always been a frozen wasteland. Instead, Antarctica emerges as a dynamic, living world, whose story has been carefully preserved beneath layers of ice and stone. The fossil forests also illuminate the profound transformations that have reshaped the planet. Over tens of millions of years, Antarctica drifted from warmer latitudes to its current polar position, subject to dramatic cooling and the onset of glaciation. The forests, once vibrant and abundant, were gradually encased in ice, their growth stifled, yet preserved in remarkable detail. Fossilized wood and leaves serve as witnesses to this dramatic transition, providing insight into the resilience of life in the face of environmental upheaval. They tell us that ecosystems are both fragile and persistent. Fragile in the face of catastrophic change, persistent in their ability to leave traces that endure far beyond their physical lifetimes. The process of uncovering these ancient forests is as much an act of patience as it is of science. Researchers must navigate treacherous glaciers, unpredictable weather, and the isolation of a continent unlike any other. With careful drilling, excavation, and sediment analysis, they bring to light fragments of trees that have been hidden for millions of years. Each discovery is a moment of revelation, a connection to a world that existed before humanity. Fossilized wood, pollen, and leaf imprints are carefully studied, revealing details about growth patterns, species diversity, and the ecological networks that once thrived here. These moments are not merely scientific. They are deeply emotional, evoking awe and reverence for life that existed so long ago, preserved so perfectly beneath the ice. There is also a haunting beauty to the fossil forests. Imagine sunlight filtering through the dense canopy of a prehistoric grove, leaves rustling in warm breezes, the forest floor carpeted with moss and ferns. Birds, insects, and other creatures once moved through this space, completing a web of life that sustained itself for countless generations. Today, all that remains are frozen fragments, yet these remnants convey a remarkable sense of vitality. The textures of petrified bark, the delicate structures of leaves, and the preserved forms of roots all offer a tactile connection to life that existed long before our own. Standing before these remnants, one can almost sense the hum of a world that no longer exists in physical form, yet endures in memory, detail, and story. The fossil forests also hold lessons about climate and adaptation. By analyzing the distribution and types of plants preserved in ice and sediment, scientists reconstruct ancient climates, identifying periods of warmth, rainfall, and even drought. These reconstructions reveal how ecosystems responded to environmental pressures, shedding light on the resilience and vulnerability of life. Fossil evidence suggests that Antarctica's forests thrived under conditions markedly different from those of today, reminding us that Earth's climate is not static and that ecosystems must continually adapt or face disappearance. The preservation of these forests under ice is both extraordinary and instructive, highlighting the delicate balance between life and environment and the incredible capacity of natural processes to conserve memory across millions of years. Beyond their scientific significance, these forests evoke wonder and reflection. There is a sense of intimacy in handling a fragment of fossilized wood, a connection across vast spans of time that is both humbling and exhilarating. Each tree, each leaf, each spore encapsulates a narrative that extends far beyond human history, reminding us of the fleeting nature of life and the permanence of change. Antarctica, in this sense, is not just a continent but a living archive, a museum without walls where the exhibits are frozen, waiting for those willing to seek them out and listen to their stories. The forests beneath the ice are silent yet eloquent, bearing witness to life that once thrived, endured, and ultimately transformed, leaving traces for generations yet to come. As explorers delve further into these frozen archives, the sense of awe deepens. The fossil forests are both evidence and metaphor, illustrating the endurance of life even in the face of unimaginable challenges. They reveal the artistry of nature, the intricate web of relationships that sustained ecosystems long ago, and the extraordinary preservation that allows us to glimpse them today. Every trunk, leaf, and root fragment is a chapter in a story that spans millions of years, a narrative that merges science with poetry, observation with imagination, and discovery with reflection. And so, Antarctica's hidden forests stand as enduring monuments to a world lost to time, yet preserved in remarkable detail. They are not merely scientific curiosities. They are reminders of the profound resilience of life, the inevitability of change, and the importance of patience, observation, and reverence. The continent, frozen and silent, holds its secrets with quiet authority, inviting those who are willing to seek to learn and to honor the extraordinary narrative written beneath the ice. The fossil forests whisper across time, urging us to imagine the lush landscapes that once existed, to study the lessons encoded in their preservation, and to marvel at the beauty and complexity of life that endures even when hidden from sight. The fossil forests beneath Antarctica are more than silent witnesses. They are living archives, carefully recording the drama of life and the relentless passage of time. As explorers and scientists study these remnants, they uncover intricate details that reveal not only the physical characteristics of ancient trees, but also the ecosystems they once sustained. Petrified conifers, ferns, and cycads provide evidence of diverse habitats, some dense and shaded, others open to sunlight, each interacting with microclimates, soil compositions, and ancient waterways. Fossilized roots intertwine in the sediment, suggesting complex networks of life where plants competed and collaborated, and where every organism had a role in the thriving web of existence. This frozen world, though hidden beneath ice, tells a story of vibrancy, resilience, and ecological sophistication that challenges modern assumptions about Antarctica as a barren wilderness. The preservation of these forests is nothing short of miraculous. Ice and sediment, acting as natural time capsules, have halted decay and safeguarded delicate structures. Leaf imprints, pollen grains, and microscopic spores remain intact, providing crucial evidence of species diversity, growth patterns, and climate conditions. Each discovery is a revelation, a glimpse into an ecosystem that existed long before humans could record it. The fossilized trees and undergrowth are not just objects of study, they are storytellers, narrating chapters of Earth's history that span millions of years. Every branch, every layer of sediment carries a message of survival, transformation, and the inexorable forces that shaped the continent into the frozen landscape we know today. Antarctica's fossil forests also illuminate the planet's broader climatic and geological history. Over millions of years, tectonic drift transported the continent from temperate latitudes to its current polar position, dramatically altering its climate. Prehistoric forests, once bathed in sunlight and nourished by rainfall, faced cooling temperatures, shorter growing seasons, and the gradual advance of glaciers. Fossils capture the remnants of this transition, recording the resilience of ecosystems and their eventual entombment beneath ice. By analyzing these layers, scientists reconstruct past climates, identifying periods of warmth, shifts in precipitation, and the environmental pressures that led to profound ecological change. The fossil forests, therefore, are both witnesses and evidence, linking the biology of the past to the geology of the present. The act of uncovering these forests is itself a narrative of endurance. Scientists navigate treacherous glaciers, withstand fierce winds, and contend with sub-zero temperatures to access sites where fossils lie buried. Ice cores and sediment samples are extracted with painstaking care, each fragment cataloged and studied to preserve the integrity of the discovery. The process is slow, deliberate, and meticulous, yet each finding rewards patience with glimpses of an ancient world. Fossilized trees reveal their secrets gradually. The curvature of a branch, the texture of bark, the pattern of leaf veins, all telling the story of a forest that once existed in abundance. These discoveries are both scientific and poetic, blending data with narrative, observation with imagination, and measurement with wonder. Beyond their scientific value, the fossil forests evoke a profound sense of connection. To stand before a petrified grove is to witness the continuity of life across geological time. There is an intimacy in handling a fragment of fossilized wood, a sense of touching the pulse of a world that no longer exists in its original form. One can imagine sunlight filtering through the canopy, the whisper of wind through leaves, and the quiet hum of life that once animated the forest floor. Even in its frozen state, the fossil forest is alive in memory, offering a tactile link between past and present, between life that once thrived and the researchers who bear witness. The fossil forests also provide lessons in resilience and adaptation. By examining the structure and distribution of plant remains, scientists gain insight into how ecosystems respond to environmental pressures. The ancient forests reveal species that adapted to shifting climates, changes in soil composition, and variations in water availability. They show the balance between competition and cooperation, survival and extinction. Each fossil is a reminder that ecosystems are dynamic, shaped by both biological and environmental forces, and that life, even when threatened by dramatic change, leaves behind traces that endure. Antarctica's forests beneath the ice are therefore both records of the past and mirrors for understanding the challenges facing ecosystems today. There is also a stark beauty to these discoveries. The contrast between lush prehistoric forests and the stark whiteness of modern Antarctica evokes a sense of awe. Fossilized trees, preserved with astonishing detail, emerge from ice that has entombed them for millions of years. Leaf imprints and wood textures speak of life, growth, and seasons long gone. The juxtaposition of past abundance with present desolation emphasizes the fragility of ecosystems and the forces of change that shape our planet. It is a reminder that beauty is not confined to the visible present. It can endure, hidden and silent beneath layers of ice, waiting for those who are patient enough to discover it. As night falls over the frozen plains, Antarctica transforms into a realm of subtle contrasts. The aurora dances across the sky, casting ephemeral colors over the wide expanse. Shadows deepen and the silence becomes almost tangible, a living presence that envelopes the landscape. Beneath the ice, the fossil forests remain untouched, silent yet eloquent. They bear witness to life that once flourished, to the transformations of climate and continent, and to the resilience of ecosystems that left enduring traces. Each fossilized fragment is a bridge across time, connecting present observers with a world both alien and familiar, and inviting reflection on the delicate balance between life and environment. In contemplating these forests, one realizes that Antarctica's story is far more complex than its icy surface suggests. The continent is a repository of ecological memory, a place where life's history is etched into rock, sediment, and ice. The fossil forests are living reminders that even the harshest climates cannot erase the traces of life entirely. They endure in forms both visible and hidden, preserved with remarkable fidelity. To explore them is to engage with the continuity of life, the inevitability of change, and the extraordinary persistence of memory beneath layers of frozen time. And so, the forests beneath Antarctica's ice remain both mystery and revelation. They are not merely remnants of the past, but enduring lessons in survival, adaptation, and resilience. Each tree, each leaf, each spore is a storyteller, narrating the drama of life that unfolded long before humans existed. To witness them is to feel the weight of time, to connect with the rhythms of life across millions of years, and to marvel at the astonishing capacity of the planet to preserve its history in the face of relentless change. Antarctica's fossil forests are silent yet profound, a testament to the enduring beauty, fragility, and resilience of life beneath the ice. The final revelations of Antarctica's fossil forests lie not just in the trees themselves, but in the stories they whisper about the resilience and fragility of life. Beneath layers of ice, perfectly preserved specimens tell of ecosystems that were once lush, diverse, and dynamic. Conifers towered above ferns, cycads flourished in humid soils, and mosses carpeted the ground in delicate green. Rivers and streams meandered through these landscapes, carrying life-giving water that nourished roots and transported nutrients. The fossil forests encapsulate not merely the physical presence of ancient life, but the intricate relationships that sustained it, the subtle balances that allowed ecosystems to flourish across millions of years, and the vulnerability that eventually led to their entombment beneath ice. Each fossilized tree trunk is a silent chronicle, inscribed with the rhythm of seasons long gone. Rings of growth capture cycles of wet and dry, warmth and cold, resilience and stress. Leaf imprints reveal the diversity of plant life and the adaptations that allowed these forests to survive environmental fluctuations. Even fragments of root systems speak of competition, collaboration, and survival strategies developed over geological time. In their frozen stillness, the forests seem timeless, yet each detail conveys a story of dynamic life, of struggle and endurance, and of ecosystems finally attuned to a climate that is now unimaginable beneath the Antarctic ice. The fossil forests also reveal a broader narrative of Earth's climatic evolution. Millions of years ago, Antarctica was a temperate, verdant continent, teeming with flora that could only survive in warmer conditions. As tectonic plates shifted and the continent drifted toward the South Pole, temperatures fell, glaciers formed, and the once thriving forests were gradually encased in ice. Fossilized pollen, spores, and wood fragments allow scientists to reconstruct these changes, providing evidence of warming and cooling cycles, rainfall variations, and the environmental pressures that shaped life. Each fossil becomes a page in a chronicle of transformation, illustrating the interplay between life and climate, adaptation and survival, and abundance and loss. The work of uncovering these forests is both physically demanding and emotionally profound. Teams of scientists navigate glaciers, cross crevasses, and endure extreme cold to access sites where fossils lie buried. Ice cores are extracted with painstaking precision, sediment layers carefully studied, and fossilized material analyzed in minute detail. Every discovery is a bridge across time, a connection to ecosystems that existed tens of millions of years before humans walked the earth. Handling a fossilized trunk or examining the intricate patterns of a leaf imparts a visceral sense of continuity, an awareness of the vast scales of time that surpass human lifespans yet remain accessible through these preserved remnants. The emotional resonance of these forests is heightened by their contrast with the stark modern landscape. Today, Antarctica is dominated by white, windswept expanses, glaciers, and jagged mountains. It is a place of silence, of desolation, and of extreme conditions. Yet beneath this frozen facade lies a memory of life, of color, movement, and growth. Fossilized forests remind us that the land we perceive as barren is a layered narrative, preserving the traces of ecosystems that adapted, survived, and ultimately succumbed to the inexorable advance of ice. This contrast evokes awe, reflection, and humility, for it demonstrates both the fragility and resilience of life on Earth. The fossil forests also serve as a warning and a lesson. They illustrate how climate, environmental shifts, and geological forces can transform thriving ecosystems into preserved archives. Life adapts where it can, yet even the most resilient species are ultimately subject to forces beyond their control. Studying these ancient forests allows scientists to better understand past climate dynamics, ecosystem responses, and the potential consequences of ongoing global change. Antarctica's fossilized landscapes become mirrors for the present, urging reflection on the delicate balance of modern ecosystems and the enduring consequences of environmental disruption. As explorers conclude their work for the day, the Antarctic sky often erupts in ethereal color. The aurora australis casts shimmering greens, purples, and pinks across the ice, illuminating the frozen landscape with fleeting beauty. In this light, the fossil forests beneath the ice seem almost alive, whispering across time, revealing themselves through the meticulous work of discovery and analysis. They are reminders that life leaves traces, that ecosystems endure in memory and matter, and that understanding the past is essential for appreciating the present and safeguarding the future. In contemplating these forests, one comes to understand the magnitude of time and the persistence of life. Antarctica's fossilized groves are more than objects of curiosity. They are eloquent narrators of planetary history, carrying lessons of adaptation, survival, and endurance. They invite both scientific study and poetic reflection, offering insight into the richness of a continent that seems desolate, yet preserves a world of intricate life beneath its frozen veneer. Each fossil, each fragment, is a bridge across millions of years, connecting us with a past that is distant, yet intimately tied to the processes shaping the Earth today. And so, the forests beneath Antarctica's ice endure in quiet majesty. They are archives of life, preserved with extraordinary fidelity, waiting for patient observers to uncover and interpret their stories. They speak to the resilience of nature, the inevitability of change, and the beauty of ecosystems that once thrived against a backdrop of climatic transformation. These fossil forests are both memory and message, a testament to life's capacity to endure, and an enduring invitation to explore, understand, and honor the profound legacy of the silent continent. As the aurora fades and the Antarctic night deepens, the fossilized forests remain eternal witnesses, hidden beneath ice yet vibrant in their preserved detail. They close Chapter 2 with a profound reminder. Beneath every layer of ice, beneath every seemingly barren expanse, lies the memory of life, waiting patiently to be discovered. Antarctica is not merely a frozen wasteland, it is a living chronicle, and the forests beneath its ice are among its most eloquent storytellers. Long before Antarctica became a realm of ice and relentless winds, it was a land of warmth, humidity, and extraordinary life, a world that seems almost unrecognizable today. Paleobotanical evidence paints a vivid picture. Vast forests stretching across the continent, rivers threading through valleys, and skies filled with clouds heavy with moisture. Fossilized plant remains, preserved in ice and sediment, speak of a temperate, even subtropical climate where ferns, cycads, and towering conifers thrived. The fossil forests beneath the ice are not just remnants of life. They are records of a climate that no longer exists, a testimony to the planet's ability to shift and transform on scales far beyond human comprehension. The study of Antarctica's lost climate begins with its fossils. Leaf structures, growth rings, and pollen grains preserved in rock and ice allow scientists to reconstruct temperature, rainfall, and seasonal variation with remarkable precision. Each fossilized specimen tells a story of environmental conditions that supported diverse ecosystems. Conifer trunks reveal periods of rapid growth, indicating warmth and ample sunlight, while fern imprints suggest moist soils and temperate air. These data, combined with sediment analysis and isotopic studies, create a detailed portrait of a continent that was once a cradle of life, thriving under conditions profoundly different from the frozen desert we see today. The lost climate of Antarctica is inseparable from its geological history. Over tens of millions of years, tectonic shifts transported the continent from warmer southern latitudes toward its polar position. This drift, combined with global cooling events, reshaped ecosystems, gradually replacing lush forests with ice and snow. Fossil records show how flora adapted or failed to adapt to these changes, providing insight into the resilience and vulnerability of life. Ancient river channels, lake beds, and soil deposits reveal periods of stability and upheaval, chronicling cycles of growth, decay, and preservation. Antarctica's fossil forests are thus climate archives, capturing the intimate interplay between the atmosphere, the land, and the living organisms that once inhabited it. The implications of this lost climate extend far beyond Antarctica. Understanding past conditions illuminates global climate dynamics, revealing how continents, oceans, and atmospheric systems interact over geological timescales. Fossil evidence indicates periods of greenhouse warmth when polar regions were habitable and ice-free, followed by gradual cooling and the onset of glaciation. These cycles help scientists model Earth's climate system, providing context for contemporary discussions about environmental change, carbon cycles, and the limits of ecosystem resilience. Antarctica's buried forests are not merely curiosities. They are critical data points, enabling us to understand how life responds to dramatic shifts in temperature and precipitation. Field studies in Antarctica are acts of temporal exploration, uncovering clues to a world long lost. Researchers carefully extract ice cores and sediment samples, examining fossilized leaves, wood, and pollen to reconstruct the climate of the past. Each layer of sediment tells a different story. Some mark periods of warmth and fertility, others the slow encroachment of cooling and ice. By analyzing isotopic ratios and plant morphology, scientists can infer temperatures, precipitation levels, and even seasonal cycles. Fossilized forests become proxies for understanding the past, providing a tangible record of conditions that existed millions of years before the continent became a frozen wasteland. One of the most striking revelations of Antarctica's lost climate is the diversity of ecosystems that once existed. Fossil evidence shows that different regions of the continent supported distinct biomes, from dense forests to open woodlands, from humid valleys to slightly drier ridges. This heterogeneity suggests that climate was not uniform, but varied across space and time, creating microhabitats that allowed species to adapt and thrive. The fossil record captures these nuances, revealing forests that supported intricate food webs, rivers that nourish plant and animal life, and soils that sustained diverse flora. Even the smallest fragment of fossilized leaf or spore adds to our understanding of these ancient landscapes, painting a picture of life in abundance and resilience. The fossil forests also reveal dramatic climate transitions. Growth rings in trees indicate periods of rapid expansion, perhaps during warmer, wetter epochs, followed by slower growth in cooler, drier periods. Leaf morphology changes suggest adaptations to shifts in sunlight, temperature, and humidity. These subtle clues allow scientists to map cycles of climatic change with astonishing clarity, showing how ecosystems responded, adjusted, and ultimately succumbed to the relentless advance of ice. Antarctica's lost climate is thus not merely an abstraction. It is a series of tangible, observable transformations that echo across millions of years, preserved in stone, ice, and fossilized wood. There is a profound emotional resonance in reconstructing a climate that no longer exists. To imagine Antarctica as a temperate, verdant land challenges deeply ingrained perceptions of the continent as barren and inhospitable. Fossilized forests beneath the ice invite wonder, curiosity, and reflection, urging us to see the planet as dynamic, ever-changing, and capable of sustaining life in forms that might seem impossible today. Each fossil is a portal, a connection to warmth, sunlight, and ecological abundance in a place now dominated by cold and silence. It is a reminder that Earth's history is vast, intricate, and full of surprises, and that understanding the past is essential for comprehending the present and anticipating the future. The lost climate of Antarctica also serves as a cautionary tale. Fossil evidence shows how ecosystems adapted, migrated, or perished in response to changing conditions. Species that could not cope with cooling and glaciation vanished, leaving behind traces preserved in sediment and ice. These patterns resonate with contemporary concerns about climate change, ecosystem collapse, and the limits of adaptability. Antarctica's fossil forests are a stark reminder that life is resilient but not invincible, and that environmental shifts, if rapid or extreme, can leave lasting marks on the biosphere. And so, Antarctica's lost climate emerges not only as a scientific mystery, but as a story of transformation, resilience, and fragility. Fossil forests preserve evidence of warmth, abundance, and ecological complexity, even as ice slowly claimed the land. They reveal a world where life adapted, flourished, and ultimately succumbed to forces beyond its control, leaving behind enduring lessons for scientists, explorers, and all who seek to understand the history of our planet. The continent, silent and frozen today, holds within it the echoes of warmth and vitality, waiting for those willing to uncover its buried secrets. The fossil record of Antarctica's lost climate is a window into a world transformed, revealing not only the flourishing of life, but the profound changes that reshaped the continent over millions of years. Tree rings, leaf structures, and pollen grains serve as natural archives, recording fluctuations in temperature, precipitation, and atmospheric conditions. Conifers that once dominated the landscape show growth patterns suggesting warmth and moisture, while delicate ferns and cycads indicate fertile soils and stable ecosystems. Every fossilized fragment is a note in the grand symphony of life, a chronicle of a climate that nurtured diversity and abundance long before the first glaciers formed. These ancient records demonstrate that Antarctica's climate was far from uniform. Different regions hosted distinct ecosystems, with microclimates shaped by elevation, water availability, and latitude. Valleys may have harbored dense forests, while higher ridges supported more open vegetation. Lakes, rivers, and wetlands sustained plant and animal life, creating ecological mosaics that adapted to the rhythms of seasonal change. Fossils captured this heterogeneity with astonishing detail. Variations in leaf size, thickness, and stomatal density reveal responses to sunlight, temperature, and atmospheric carbon dioxide levels. The continent, now a monochrome expanse of ice, was once a mosaic of life, diversity, and complex interactions. Each fragment of fossil evidence a testament to the lost climate that supported it. The transition from a warm, verdant Antarctica to the frozen desert of today was gradual but relentless. As tectonic forces shifted the continent southward, and as global cooling events took hold, ecosystems faced mounting pressures. Fossilized forests provide clues to this transformation. Periods of rapid growth give way to slower rings. Changes in leaf morphology suggest adaptations to cooler, drier conditions, and sediment layers indicate shifts in hydrology and soil fertility. These records are not abstract. They are tangible evidence of life responding, adapting, and ultimately being overtaken by forces beyond its control. Antarctica's lost climate is preserved in these minute details, a reminder of both the resilience and vulnerability of ecosystems. Ice cores and sediment layers act as time capsules, capturing snapshots of climate change across epochs. Within these layers lie pollen grains, spores, and microscopic plant fragments that reveal not only temperature and precipitation patterns, but also atmospheric composition. By analyzing isotopic ratios, scientists can reconstruct levels of greenhouse gases and infer global climatic conditions. These records demonstrate that Antarctica was once a world of warmth, humidity, and flourishing vegetation, challenging preconceived notions of the continent as eternally frozen. The fossil forests are a living archive, offering insight into how life thrived under conditions radically different from the present, and how it gradually succumbed to the inexorable advance of ice. The ecological richness of this lost climate is evident in the diversity of plant species preserved. Fossilized conifers stand alongside ferns, mosses, and cycads, while ancient riverbanks and lakebeds hint at aquatic vegetation that once lined the shores. These ecosystems were interconnected, with each species playing a role in nutrient cycling, habitat structure, and energy flow. Fossil evidence even suggests the presence of insects and other small organisms that depended on the vegetation, creating intricate webs of life. In studying these remains, scientists glimpse the dynamics of entire ecosystems, understanding not just individual species, but the relationships that sustained them. Antarctica's lost climate was a stage for life's interplay, a testament to nature's complexity and adaptability. The preservation of these ecosystems beneath ice is extraordinary. Layers of sediment and frozen soil halted decomposition, creating a meticulous record of life that endures to this day. Fossils capture fine details, from the veins of leaves to the cellular structure of wood, providing insight into physiology, growth patterns, and environmental stressors. Each discovery is a revelation, allowing researchers to reconstruct the climate with remarkable accuracy. These frozen archives serve as both scientific treasure and poetic reminder, connecting the present observer with a world that existed tens of millions of years ago, a world where warmth, life, and abundance reigned across a continent now dominated by cold and ice. There is an emotional dimension to uncovering Antarctica's lost climate. To visualize a temperate, verdant continent beneath layers of ice is to confront the impermanence of life and the fluidity of Earth's environmental history. Fossil forests evoke wonder and reflection, bridging the gap between imagination and evidence. Standing over a petrified grove, one can almost sense sunlight filtering through leaves, the gentle hum of life, and the delicate balance that sustained ecosystems. It is a connection across time, a tangible reminder that life has endured extraordinary change and that understanding these past climates is essential for appreciating the fragility and resilience of Earth's present ecosystems. The lost climate of Antarctica also illuminates broader patterns of global change. Fossil evidence shows how polar warming periods influenced flora and fauna, how shifts in greenhouse gases affected ecosystems, and how continents drifting through different latitudes experienced transformations that reshaped biodiversity. These insights are crucial for modern climate science, providing context for understanding how ecosystems might respond to contemporary shifts in temperature, precipitation, and carbon levels. Antarctica's buried forests are more than historical curiosities. They are models of ecological resilience, lessons from the deep past about adaptation, survival, and the consequences of environmental disruption. And so, Antarctica's lost climate emerges as a story of transformation, resilience, and wonder. The fossil forests preserved beneath the ice are tangible records of warmth, fertility, and life, capturing the rhythm of seasons, the interplay of ecosystems, and the extraordinary adaptation of flora to changing conditions. They remind us that Earth's history is vast, dynamic, and full of surprises, and that beneath the frozen surface lies a world that once teemed with life, now waiting for careful study and reflection. In this hidden archive, the planet's story is preserved with astonishing fidelity, offering lessons that span millions of years and extending an invitation to witness the deep history of life on Earth. The story of Antarctica's lost climate is not just one of warmth and greenery. It is a story of transformation and survival on a scale almost impossible to comprehend. Fossilized forests reveal that millions of years ago, this southernmost continent experienced seasons, rainfall patterns, and temperatures that rivaled modern temperate regions. Conifer trunks, meticulously preserved, show alternating bands of rapid and slow growth, evidence of cyclical variations in climate periods of abundance and periods of stress. Ferns, mosses, and cycads, delicately imprinted in sediment, suggest soils rich in nutrients and moisture, nurturing diverse ecosystems that thrived long before ice began its inexorable advance. The fossil record captures subtle shifts in vegetation that hint at the early stages of climatic change. Slight variations in leaf size, stomatal density, and growth orientation reflect the continent's gradual cooling as tectonic drift moved it toward polar latitudes. These small changes, imperceptible in the living moment, become profound indicators in retrospect, revealing how life adapted or, in some cases, failed to adapt to shifting environmental pressures. The forests beneath Antarctica's ice are therefore more than remnants of life. They are active records of ecological resilience, chronicling the ongoing negotiation between species and the climate that sustained them. Ancient riverbeds, lake deposits, and sediment layers provide additional clues to the lost climate. Water was once abundant, flowing through valleys and nourishing the soil. Lakes supported aquatic plants, while wetlands became havens for mosses and ferns. Fossilized spores and pollen trapped in sediment reveal the timing and extent of seasonal changes, indicating periods of heavy rainfall, drought, and temperature fluctuations. Even subtle features, such as leaf orientation and branch structure, inform scientists about wind patterns, sun exposure, and environmental stresses. Antarctica's lost climate is not an abstraction. It is a tangible system, reconstructed through careful observation of these enduring records. The transformation from warmth to ice was neither sudden nor uniform. Fossil evidence shows periods of stability interspersed with abrupt cooling events. Forests contracted and expanded, species migrated or perished, and ecosystems were reshaped by the gradual accumulation of glaciers. These dynamics are recorded in growth rings, sediment layers, and the distribution of fossilized plants. Each piece of evidence contributes to a complex narrative, a continent once alive with vibrant ecosystems slowly succumbing to an unforgiving environment. By studying these shifts, scientists gain insight into the mechanisms of adaptation and extinction, and the intricate balance between climate, geology, and life. The ecological diversity of ancient Antarctica is remarkable. Fossilized conifers towered above ferns and mosses, while cycads and smaller shrubs filled the understory. Rivers and lakes supported vegetation that in turn nourished insects and other small organisms. This interconnected web of life reflects a continent that, despite its remote location, hosted a range of microhabitats. Fossil evidence even suggests that some regions experienced more rainfall than others, creating pockets of particularly lush forest. These findings underscore the complexity of Antarctica's lost climate. It was not a monolithic environment, but a dynamic system of variation, adaptation, and interdependence. Uncovering these ancient records requires extraordinary effort and precision. Scientists navigate glaciers, drill ice cores, and carefully extract sediment and fossilized material, often under extreme conditions. Each fragment must be meticulously documented and analyzed, for even a single leaf or piece of wood can reveal critical information about climate, temperature, and ecosystem dynamics. The painstaking process of excavation mirrors the careful negotiation required by the ancient forests themselves as they responded to changing conditions. Each discovery bridges millions of years, connecting the present observer with a continent alive in a time long past. There is a haunting beauty in contemplating Antarctica's lost climate. Today, the continent is dominated by ice, wind, and silence. Yet beneath this frozen surface lies a vibrant, green world, preserved in fossilized form. Leaf imprints and petrified trunks evoke images of sunlight filtering through branches, rivers glinting in the distance, and ecosystems thriving in harmony with their environment. Fossil evidence transforms imagination into knowledge, allowing us to reconstruct landscapes, seasons, and life forms that existed long before human eyes could behold them. It is a reminder of the impermanence of life and the endurance of memory. The lost climate of Antarctica also serves as a lesson for our time. Fossil forests reveal how ecosystems respond to environmental pressures, adaptation, migration, or disappearance. The evidence of past warming and cooling events, of thriving and fading forests, underscores the delicate balance between life and climate. These ancient lessons resonate today, offering insight into the challenges facing modern ecosystems under the pressure of global climate change. Antarctica's buried forests are both record and warning, a reminder that life is resilient but vulnerable, and that the planet's climate has the power to transform landscapes, ecosystems, and species across millennia. And so, the fossilized forests beneath Antarctica's ice are more than remnants. They are storytellers of a lost climate, narrating epics of warmth, fertility, and abundance. They reveal the rhythms of seasons, the interplay of ecosystems, and the extraordinary adaptation of life to its environment. They challenge perceptions of Antarctica as eternally frozen, inviting reflection on the dynamism of Earth's climate system and the resilience of life in the face of change. Each leaf, trunk, and spore is a messenger across time, connecting the present with the deep past and illuminating the intricate tapestry of life that once flourished beneath the southern sun. As the sun sets over the frozen expanse, casting long shadows across glaciers and ice sheets, one cannot help but feel the magnitude of time and the fragility of ecosystems. Antarctica's lost climate is preserved not only in rock and ice, but in the imagination and dedication of those who study it. The fossil forests beneath the ice endure as silent witnesses, whispering stories of life, warmth, and resilience, waiting for patient observers to uncover their secrets. In their preservation lies both knowledge and wonder, a bridge across millions of years, and a testament to the enduring legacy of life on a changing planet. As we delve deeper into Antarctica's ancient climate, a picture emerges of a continent profoundly different from the icy expanse we know today. Fossil evidence paints a world of warmth, moisture, and life, a landscape where towering conifers stretched skyward. Ferns carpeted the forest floor, and cycads thrived in sheltered valleys. Rivers meandered through fertile soils, creating wetlands and lakes that nourish both flora and fauna. Fossilized pollen, spores, and plant fragments captured the vibrancy of these ecosystems, revealing the astonishing diversity of a climate that sustained life in abundance. Each fossil is a whisper from a past world, a testament to the conditions that allowed forests to flourish in the far south. The fossil record also reveals the subtle yet relentless influence of climatic change over millions of years. Growth rings in petrified trees show periods of rapid expansion during warm epochs, followed by slower growth in cooler, drier conditions. Leaf morphology indicates adaptations to shifts in sunlight, temperature, and moisture availability. Sediment layers capture floods, droughts, and seasonal variations, preserving an ecological narrative that chronicles both prosperity and struggle. Antarctica's lost climate was not static. It evolved, responded, and challenged life at every turn. The fossilized forests provide a window into this dynamic system, offering unparalleled insight into the resilience and adaptability of ecosystems in the face of environmental stress. Ice cores extracted from glaciers reveal further evidence of Antarctica's temperate past. Trapped within the frozen layers are traces of greenhouse gases, atmospheric compositions, and isotopic signatures that provide a timeline of climatic shifts. These records correlate with fossil data, allowing scientists to reconstruct temperature fluctuations, precipitation patterns, and seasonal cycles. Together, they reveal a continent that transitioned gradually from warmth to ice, illustrating the interplay between local ecosystems and global climate processes. Antarctica's lost climate emerges as a detailed, living system, preserved with remarkable fidelity for those patient enough to decipher its messages. The diversity of ecosystems across the continent is particularly striking. Fossil evidence shows that some regions supported dense, multi-layered forests, while others were open woodlands or shrublands. Lakes and rivers nourished wetlands, fostering ferns, mosses, and smaller plants that thrived in moist conditions. Fossilized wood, leaves, and spores indicate a rich tapestry of life, from towering conifers to delicate understory plants. Even the smallest fragments contribute to our understanding of these habitats, revealing how different species interacted, competed, and collaborated within complex ecological networks. Antarctica's lost climate was a mosaic of microhabitats, each shaped by subtle variations in temperature, moisture, and sunlight. The fossil forests also illuminate the gradual encroachment of glaciation and cooling. Over millions of years, tectonic shifts moved the continent closer to the South Pole, and global temperatures declined. Fossilized tree rings record slower growth, leaf structures indicate stress, and sediment layers show the advance of ice. These changes were neither sudden nor uniform, but they reshaped ecosystems with inexorable force. Species that could adapt survived longer. Others perished, leaving behind traces that would endure for tens of millions of years. The fossil record is therefore a chronicle of resilience, adaptation, and ultimately, transformation, a narrative written not in words, but in wood, leaves, and sediment. The act of uncovering these fossils is itself a testament to human perseverance. Researchers endure extreme cold, navigate glaciers and crevasses, and extract fragile specimens with meticulous care. Each discovery connects the present with a distant past, revealing details of climate, vegetation, and ecosystem dynamics preserved in ice and rock. Fossilized trunks, leaves, and pollen are not simply objects of study. They are portals to another world, allowing us to witness the rhythms of ancient seasons, the flow of rivers, and the dance of life under a southern sun long gone. Antarctica's lost climate is experienced not only through data, but through imagination, empathy, and awe. The emotional impact of this realization is profound. To imagine a warm, fertile Antarctica beneath the endless ice evokes wonder, humility, and reflection. Fossilized forests are more than scientific evidence. They are narratives of endurance, persistence, and change. They invite us to consider the vast scales of time, the fragility of ecosystems, and the remarkable adaptability of life. Every leaf imprint, trunk fragment, and spore is a message across millions of years, reminding us that the world is ever-changing, that life persists, and that understanding the past is essential to navigating the future. Antarctica's lost climate also informs our understanding of global ecological processes. Fossil evidence reveals how shifts in temperature, atmospheric composition, and precipitation influence vegetation patterns, species distribution, and ecosystem resilience. These insights have direct implications for modern climate science, providing context for understanding how ecosystems respond to environmental stress, how species adapt or vanish, and how continents interact with the atmosphere and oceans over geological time. The fossil forests beneath the ice are both archives and teachers, offering lessons in adaptation, survival, and the consequences of climate change. And so, as the sun dips behind distant icebergs and the Antarctic night deepens, the fossilized forests beneath the continent's frozen surface continue their silent narration. They are more than remnants of life. They are the record of a lost climate, a story of warmth, abundance, and transformation preserved in ice and sediment. Each fossil, each ring, each leaf imprint is a bridge across time, connecting the modern observer to a world that existed millions of years ago. In their preservation lies both knowledge and wonder, a testament to life's resilience and the enduring mystery of Antarctica's lost climate. The fossilized forests beneath Antarctica are silent witnesses to a climate that existed long before humanity, a climate of warmth, moisture, and life that defies the frozen desolation of today. Each petrified trunk, each leaf imprint, and each layer of sediment is a fragment of this ancient world, preserved in exquisite detail. These remnants speak not only of vegetation, but of the environment that sustained it, the rivers, wetlands, and fertile soils, the humidity, temperature, and seasonal cycles that shaped ecosystems. Antarctica's lost climate is recorded in these fossils, a story written in the language of growth rings, leaf structures, and pollen grains, waiting patiently to be read. The transformation of Antarctica from a temperate, thriving continent to a vast ice sheet was gradual but relentless. Fossil evidence captures this slow march. Rings in tree trunks indicate periods of slower growth. Leaves show adaptations to changing light and temperature, and sediment layers reveal the advance of glaciers and the retreat of rivers. Ecosystems that once thrived in warmth and abundance face cooling temperatures, shrinking habitats, and the inexorable encroachment of ice. Species adapted where they could, migrated where possible, and perished where survival was no longer feasible. The fossilized forests are the preserved testimony of these struggles, a chronicle of adaptation and loss across millions of years. Ice cores provide additional insight into Antarctica's lost climate. Trapped gases, isotopic ratios, and microscopic plant fragments allow scientists to reconstruct temperatures, precipitation patterns, and atmospheric composition with astonishing precision. These scientific records corroborate the fossil evidence, revealing the complexity of climatic shifts and their impact on ecosystems. The continent was never static. It was a dynamic system, responding to global climate cycles, tectonic shifts, and localized environmental changes. Fossilized forests capture this dynamism, offering a glimpse into the mechanisms of change and the resilience of life in the face of environmental pressures. The diversity of life preserved beneath the ice is remarkable. Fossil evidence shows that some regions supported dense, layered forests, while others were open woodlands or riverine habitats. Conifers, ferns, mosses, and cycads coexisted, creating complex ecosystems with intricate interdependencies. Fossilized wood, leaves, and pollen revealed the subtle variations in growth and adaptation that allowed species to thrive under changing conditions. Even the smallest fragments, the imprint of a leaf, the cross-section of a branch, contribute to understanding the climate, soils, and ecological interactions of the past. Antarctica's lost climate was a patchwork of microhabitats, each shaped by subtle environmental differences and preserved for millennia beneath the ice. Uncovering these forests is a monumental task. Scientists brave harsh winds, sub-zero temperatures, and treacherous glaciers to access fossil sites. Every fossil must be extracted with meticulous care, documented, and analyzed to preserve the integrity of the record. Each discovery is a bridge across time, connecting modern observers with ecosystems that existed tens of millions of years ago. Handling a petrified tree trunk, examining a delicate leaf imprint, or studying a spore-laden sediment layer evokes awe and a profound sense of connection with life long vanished. These frozen archives transform abstract science into a visceral, almost spiritual experience. There is a haunting beauty to the realization that Antarctica once supported lush forests. Imagine sunlight streaming through dense canopies, rivers glinting in the distance, and a chorus of life filling the air. Fossil evidence allows us to reconstruct this world, to imagine seasons, cycles, and ecological interactions that existed under conditions radically different from the icebound continent we know today. Each tree, leaf, and pollen grain is a messenger from a past climate, carrying the story of warmth, abundance, and transformation. Antarctica's fossil forests are a reminder that the planet is ever-changing, that life adapts, and that ecosystems, even when lost, leave enduring traces. The lost climate of Antarctica also offers lessons for the present. Fossil forests reveal the consequences of gradual cooling, environmental stress, and habitat transformation. They show how ecosystems respond to change. Some species adapt, others migrate, and some vanish entirely. These patterns echo in contemporary discussions about climate change, biodiversity loss, and the fragility of modern ecosystems. Antarctica's buried forests are both record and warning, a testament to the resilience of life and the limits imposed by environmental forces. The past offers guidance for understanding the future, reminding us that ecosystems are dynamic and vulnerable, shaped by forces both immediate and immense. As the Antarctic night descends, the fossilized forests remain eternal witnesses, hidden beneath miles of ice yet vibrant in their preserved detail. They are archives of warmth, fertility, and life, narrating a story of climate, adaptation, and transformation. Each leaf, trunk, and spore is a bridge across millions of years, connecting the present to a world long vanished. In contemplating these ancient forests, we are reminded of the magnitude of time, the resilience of life, and the enduring mysteries preserved beneath the ice. Antarctica is more than a frozen desert. It is a repository of life's history, a continent that harbors both memory and lesson beneath its surface. And so, Chapter 3 closes with the profound understanding that Antarctica's lost climate is not just a scientific curiosity. It is a narrative of survival, adaptation, and transformation. The fossil forests beneath the ice are storytellers, recording warmth, fertility, and ecological complexity for the patient observer. They teach us about the rhythms of life, the inevitability of change, and the endurance of ecosystems across geological time. As explorers and scientists uncover these secrets, they illuminate a continent's hidden past, bridging the present with a world that existed millions of years before human eyes could behold it. Beneath the blinding white of Antarctica, hidden from the casual gaze, lies a landscape sculpted by forces both immense and invisible. Ice is not merely a covering. It is an artist, a chronicler, and a relentless architect, shaping mountains, valleys, and plains over millions of years. The continent's geology, hidden beneath miles of frozen layers, tells a story of transformation, erosion, and resilience, a narrative encoded in rock, sediment, and the ice itself. Each crevasse, each ridge, each undulating glacier is both evidence of movement and a memory of the forces that carved the land long before the first explorers set foot upon its surface. Glaciers dominate the continent, not as passive observers, but as dynamic agents of change. They flow, creep, and grind against rock, slowly sculpting the bedrock beneath. Through a combination of pressure, friction, and relentless movement, glaciers erode mountains, carve valleys, and transport sediments across vast distances. The result is a landscape of contrasts. Jagged peaks stand alongside smooth plains. Deep canyons yawn beneath ice sheets, and moraines and ridges hint at past glacial activity. Each formation is a record, capturing the history of the continent's geologic and climatic evolution, preserved beneath layers of frozen time. Erosion is both subtle and monumental. In some places, glaciers polish bedrock to a mirror-like sheen, while in others, they gouge deep striations that reveal the direction and intensity of past flows. Sediment carried by ice layers tells stories of distant mountains, ancient rivers, and vanished ecosystems. Fossilized fragments embedded in these deposits offer clues to Antarctica's prehistoric environment, revealing not only what lived there, but how landscapes shifted in response to climate, tectonics, and glacial movement. The interaction between ice and rock is a dance of patience and power, slow yet relentless, reshaping the continent over eons. Beneath the ice, the geology of Antarctica is astonishingly diverse. Ancient mountains, formed by tectonic collisions, rise from the bedrock, their peaks sometimes breaching the surface of the ice sheet. Volcanic formations speak of fire that once surged from deep within the earth, while sedimentary basins preserve the layers of time, capturing ecosystems and climates long vanished. Fossil forests lie entombed in some of these formations, reminding us that ice is both destroyer and preserver, capable of obliterating surface features while safeguarding fragile evidence of life beneath its frozen weight. The hidden geology is thus both a map of destruction and preservation, chronicling forces that have shaped the continent for hundreds of millions of years. Exploring this hidden world requires precision, patience, and resilience. Scientists rely on ice-penetrating radar, satellite imaging, and seismic surveys to peer beneath the frozen surface, mapping the contours of buried mountains, valleys, and rivers. Cores drilled through kilometers of ice bring fragments of rock, sediment, and even fossilized life to the surface, revealing the interplay between geology and climate over unimaginable timescales. Every sample, every measurement, offers a glimpse into processes that have shaped Antarctica in ways both visible and hidden, creating a layered narrative of erosion, deposition, and transformation that is still ongoing today. The forces of erosion are both creative and destructive. Glaciers carve canyons that become habitats for microbial life. Ice sheets grind down mountains while depositing fertile sediments that preserve evidence of ancient forests. Meltwater channels edge temporary streams through the ice, tracing routes of water flow that echo the continent's geological past. Even the smallest feature striations in bedrock, polished surfaces, or glacial till carry information about the magnitude and duration of erosive forces. In Antarctica, every ridge and groove is a chronicle of time, a record of the ceaseless struggle between ice, rock, and climate, written in forms both subtle and monumental. The hidden geology of Antarctica also illuminates the history of climate itself. Sedimentary layers, volcanic deposits, and glacial striations act as archives, preserving evidence of ancient temperatures, precipitation, and atmospheric conditions. Fossils embedded in these layers reveal what ecosystems existed before the ice advanced, offering insight into the interplay between geology and life. By studying these records, scientists reconstruct the timeline of glaciation, the advance and retreat of ice sheets, and the shifting patterns of erosion that have shaped the continent's modern surface. Antarctica's hidden geology is therefore not merely a story of rock and ice. It is a chronicle of Earth's climate, ecosystems, and planetary processes across deep time. There is a profound beauty in understanding the interplay of ice and geology. Jagged mountains emerge from the smooth flow of glaciers, their contours revealed in satellite images and aerial surveys. Hidden valleys, revealed only through radar, suggest ancient rivers and past climates. Fossilized remains embedded in rock and sediment whisper of life that once thrived, now preserved by the very ice that reshaped the land. The contrast between destruction and preservation, movement and stasis, chaos and order, evokes awe and reflection. Antarctica is a land of paradox, stark, white, and inhospitable on the surface, yet rich with geological and ecological memory beneath. Ice is not static. It moves, reshapes, and erodes with patient insistence. Crevasses open, ice shelves calve, and glaciers grind onward, sculpting the land with the precision of geological time. Sediment carried within ice reveals distant landscapes, transporting fragments of rock and fossilized life across hundreds of kilometers. The hidden geology is a mosaic of forces, each interacting with climate, tectonics, and life to create a continent simultaneously ancient and dynamic. Every ridge, every valley, every striation is a testament to the ceaseless work of ice, a record of forces both visible and invisible shaping the southernmost land on Earth. And so, as sunlight glints off the endless expanse of white, the hidden geology beneath Antarctica's ice emerges as both archive and masterpiece. Glaciers carve, polish, and deposit. Sediment preserves. Fossils endure. The continent is a chronicle of erosion and preservation, a dynamic system sculpted over millions of years. Every measurement, every core sample, every radar image reveals new chapters in the story of ice and rock, of climate and life, patiently written and preserved beneath the frozen surface. Antarctica is not simply ice. It is a living, evolving archive of the planet's geologic past, offering insights, lessons, and wonder to those who seek to uncover its hidden depths. Beneath the surface of Antarctica, erosion is a slow, relentless sculptor. Ice, pressed under unimaginable weight, grinds rock into fine sediment, reshaping mountains and valleys over millennia. The process is both destructive and preservative. On one hand, glaciers obliterate older surfaces, smoothing jagged peaks and scraping ancient landscapes. On the other, they encapsulate fossils, sediments, and traces of prehistoric ecosystems, sealing them in a frozen archive. Each glacial movement is a layer of history, each crevasse a scar of past forces, and each moraine a remnant of the continent's dynamic transformation. The bedrock beneath the ice reveals stories of ancient mountains and vanished valleys. Some formations, composed of rock hundreds of millions of years old, have survived eons of movement and pressure, standing as silent witnesses to the forces of erosion and tectonics. Other areas are sculpted into undulating plains and striated surfaces, evidence of relentless ice movement. Satellite imagery and ground-penetrating radar expose hidden ridges and submerged peaks, revealing a terrain both majestic and alien. Even valleys, buried beneath thick ice sheets, hint at the rivers, lakes, and ecosystems that once shaped the continent's surface. Antarctica's hidden geology is a testament to the patient yet unstoppable power of natural forces, etched in rock, ice, and sediment. Glacial erosion is more than a mechanical process. It interacts intimately with climate. Warmer periods can accelerate ice flow and melt, releasing sediments and reshaping landscapes. Cooler periods slow the movement, allowing ice to compact and preserve underlying material. By examining layers of ice and embedded debris, scientists reconstruct the ebb and flow of ancient glaciers, gaining insight into the interplay between climate, erosion, and geology. Fossilized fragments trapped within these layers provide additional evidence, revealing the flora and fauna that existed before glaciation. Antarctica's glaciers are thus both sculptors and archivists, carving the land while safeguarding its past. Volcanic activity has also left its mark beneath the ice. Ancient eruptions shaped mountains, deposited layers of ash, and altered the surrounding landscape. Volcanic rocks interspersed with sedimentary layers tell of a continent that was once tectonically active, where fire and ice coexisted in a delicate balance. Fossils discovered within these layers hint at ecosystems that thrived between eruptions, resilient life that adapted to sudden disturbances. The juxtaposition of volcanic deposits and glacial erosion reveals the complexity of Antarctica's geological history, a tapestry of forces that have acted over millions of years to shape the land beneath the ice. Sediments carried and deposited by glaciers are invaluable records of hidden geology. Moraines, till, and other glacial deposits contain fragments of rock, fossils, and minerals transported from distant regions. By analyzing these sediments, scientists can trace the origins of rock formations, reconstruct past landscapes, and understand the direction and magnitude of glacial movement. Each layer tells a story of erosion, transport, deposition, and preservation. Fossils embedded within these sediments provide snapshots of life before glaciation, capturing a world that has long since vanished beneath the ice. Antarctica's hidden geology is thus not static. It is a dynamic, ever-changing archive that chronicles both natural processes and the resilience of life. The interplay of erosion and preservation creates striking contrasts in the landscape. Glacial polish smooths bedrock into reflective surfaces, while striations and grooves record the direction and intensity of ice flow. Moraines rise as jagged ridges of transported debris, hinting at past ice margins. Subglacial valleys, invisible from above, trace ancient river courses, revealing a continent that once flowed with water rather than being dominated by ice. Fossilized forests and embedded plant material within these deposits connect the geology to the paleoclimate, offering evidence of warmth, moisture, and thriving ecosystems long before the continent froze. The hidden geology is therefore a multidimensional record, uniting ice, rock, and life across time. There is a profound emotional resonance in uncovering these hidden landscapes. To realize that beneath kilometers of ice lie ancient mountains, valleys, and ecosystems is to confront the magnitude of geological time. Each discovery is a reminder that the Earth is a living system, continuously reshaped by forces far greater than human lifespans. Fossils, sediments, and glacial formations link us to epochs where life thrived under entirely different conditions, providing perspective on the fragility and resilience of ecosystems. Antarctica's hidden geology is more than a record. It is a connection to the planet's deep history, inviting both awe and reflection. Modern technology has allowed scientists to explore these frozen archives with unprecedented detail. Ice-penetrating radar, seismic surveys, and satellite imaging reveal subglacial mountains, buried valleys, and the hidden extent of glaciers. Drilled cores provide physical evidence of rock types, fossils, and sediment composition, allowing researchers to reconstruct the processes of erosion and deposition. Each layer, each striation, each fragment of rock adds to a narrative that spans millions of years, connecting tectonics, climate, and life. The continent's hidden geology is a puzzle, patiently revealing its pieces to those willing to look beneath the ice. And so, Antarctica's glaciers and hidden bedrock emerge as storytellers of a continent in motion. Ice flows, sediments shift, and fossils endure, capturing a world both ancient and dynamic. Erosion is both destroyer and preserver, shaping mountains while safeguarding the remnants of life. The hidden geology of Antarctica is not merely rock and ice. It is an archive of climate, ecosystems, and planetary change, written across millions of years. Each discovery is a bridge between past and present, a testament to the power of natural forces, and a reminder of the complexity and wonder of the silent, frozen continent. Beneath the seemingly endless white, Antarctica conceals a subterranean world shaped over eons by ice, wind, and tectonic activity. Glaciers, though slow, are powerful sculptors. They carve deep troughs, smooth, jagged peaks, and transport rock across vast distances, leaving behind a record etched into the bedrock. Each polished surface and striation tells the story of relentless movement, tracing the rhythm of glaciers over millions of years. These marks are not just scars. They are historical records, frozen in stone, revealing how ice has tirelessly reshaped the continent beneath the frozen veneer. The erosion caused by glaciers has paradoxically preserved ancient life. As ice grinds rock, it also encapsulates fossils and sediments, safeguarding them against decay. Buried beneath kilometers of ice lie petrified forests, fossilized riverbeds, and ancient soils, remnants of ecosystems that existed long before the continent became a frozen desert. Sediment cores extracted from these depths reveal traces of plant life, pollen, and microscopic organisms, offering glimpses into environments that flourished under temperate climates. Each fossil and fragment is a messenger, bridging the present with the lost worlds of Antarctica's distant past. The continent's hidden geology is astonishingly varied. Ancient mountains, shaped by tectonic collisions, thrust through ice sheets, while volcanic rock formations hint at fire long frozen in time. Subglacial lakes and river channels, buried and preserved, suggest a landscape once sculpted by liquid water rather than ice. Even in regions dominated by glaciers, bedrock formations reveal the relentless power of erosion, carving valleys, ridges, and basins. These formations not only document geological processes, but also serve as a record of climate, showing how temperature fluctuations, precipitation, and glacial advance shaped the terrain. Antarctica's geology is both canvas and archive, recording the interplay of natural forces over millions of years. The movement of glaciers is a dance between pressure, gravity, and friction. Ice sheets flow at rates measured in meters per year, yet their impact is monumental. As glaciers grind along the bedrock, they scrape, polish, and transport rock fragments, creating moraines and depositing till in their wake. These processes reveal patterns of erosion, showing the direction and magnitude of ice movement over geological time. Embedded within these glacial deposits are fossils and sediment layers that provide insight into past ecosystems. By studying these interactions, scientists reconstruct both the physical and biological history of the continent, gaining a deeper understanding of how ice shapes and preserves life. Subglacial volcanoes add a further layer of complexity. Beneath thick ice sheets, volcanic activity has left deposits of ash and lava, which have influenced both geology and climate. Heat from volcanic activity can melt overlying ice, creating subglacial lakes and channels that further reshape the landscape. Sediments from volcanic eruptions preserve evidence of ancient life, capturing ecosystems that adapted to these disturbances. The coexistence of fire and ice in Antarctica's hidden geology underscores the continent's dynamic nature, where destruction and preservation occur simultaneously, shaping a unique archive of planetary history. Sediments transported by glaciers tell stories of distant landscapes. Rocks, soil, and fossil fragments are carried hundreds of kilometers, then deposited as moraines or embedded within ice layers. Each transported fragment is a clue, revealing the origin, journey, and ultimate resting place of ancient materials. Fossilized flora within these sediments offers evidence of pre-glacial ecosystems, allowing reconstruction of past climates and environmental conditions. Antarctica's glaciers, in moving and depositing these sediments, have created a network of preserved history, each layer a chapter in the continent's geological narrative. There is a haunting elegance to this hidden world. Jagged peaks emerge from smooth glacial plains, subglacial valleys trace ancient rivers, and moraines rise like monuments to the ice's persistent passage. Fossilized remains, embedded in sediment, remind us of life that once thrived, preserved in a landscape now dominated by cold and stillness. Observing these features is to witness the interplay of creation and destruction, of movement and stasis, as the continent continues to evolve. Antarctica's hidden geology is not static. It breathes with the slow pulse of ice, a testament to the planet's enduring cycles. Technological advances have allowed scientists to explore this secret world with increasing precision. Ice-penetrating radar, satellite imagery, and seismic surveys map subglacial mountains, lakes, and valleys, revealing the contours of land unseen for millennia. Core drilling recovers rock, sediment, and fossils, allowing detailed analysis of past climates and ecosystems. These tools uncover the processes that shape the continent, providing insight into erosion, deposition, and glacial dynamics. Antarctica's hidden geology emerges as a complex archive, linking past climates with modern observations and offering a window into the forces that continue to shape our planet. And so, the continent beneath the ice is revealed not as inert and frozen, but as a dynamic, living archive of natural history. Glaciers carve, erode, and preserve. Volcanic activity leaves hidden traces. Sediments record the passage of time. Together, they tell the story of Antarctica's hidden geology, a narrative of ice, erosion, and preservation stretching across millions of years. Each striation, each morainal ridge, each fossilized fragment is a message from a world concealed beneath kilometers of ice, reminding us of the magnitude of geological time and the extraordinary resilience of life in the face of Earth's relentless forces. The hidden geology of Antarctica is a testament to the patient, inexorable work of ice over millions of years. Glaciers, vast and relentless, have carved the land with an artistry measured in millennia. Peaks once jagged and imposing have been smoothed into gentle contours. Valleys that once carried rivers are now buried beneath thick, unyielding ice. Every striation, every polished rock, every moraine tells a story of movement, pressure, and time. The landscape beneath the frozen surface is both a record of destruction and a library of preservation, chronicling a continent in constant transformation. Ice is both sculptor and preserver. As it grinds against bedrock, it pulverizes mountains into sediment and transports debris across vast distances. Yet the same ice protects delicate fossils and sediments, freezing them in place for future discovery. Petrified forests, pollen-laden soils, and fossilized riverbeds lie hidden beneath kilometers of ice, awaiting the patient work of scientists to reveal their secrets. In this frozen archive, life and geology coexist, intertwined in a delicate balance of erosion and preservation. Antarctica's glaciers are custodians of history, carrying the memory of a continent long transformed. Volcanic forces beneath the ice add another layer of complexity. Subglacial eruptions have left deposits of ash and lava, reshaping the landscape and influencing glacial movement. Heat from volcanic activity can melt overlying ice, creating subglacial lakes that flow and carve channels through rock. Fossilized remnants within volcanic deposits offer a glimpse into ecosystems that persisted despite disturbance, revealing the resilience of life in a volatile environment. The interplay of fire and ice, destruction and preservation, creates a hidden geology that is both dynamic and fragile, a narrative of contrasts preserved beneath the Antarctic ice sheet. Sediment layers embedded in glaciers are time capsules. Each moraine, till deposit, and layer of ice-transported rock contains fragments of distant landscapes, fossils, and minerals. By analyzing these layers, scientists trace the origins of rocks, reconstruct ancient environments, and uncover the trajectory of glaciers over millennia. Fossilized plant material within these sediments reveals ecosystems that flourished before the ice advanced, providing evidence of warmer, wetter climates that supported forests and wetlands. The movement of ice thus becomes a record not only of geological processes, but also of life itself, preserving snapshots of ecosystems buried beneath the frozen surface. Erosion and deposition work in tandem to shape Antarctica's hidden landscapes. Crevasses and cracks reveal the strain of ice movement. Polished surfaces show the direction and magnitude of glacial flow. Moraines rise like monuments, marking the passage of glaciers, while buried valleys hint at rivers that once carved through the land. Fossils and sediments, transported and deposited, record life that existed under conditions radically different from today's frozen desert. The continent beneath the ice is therefore a palimpsest, layered with evidence of climate, ecosystems, and geological processes, patiently revealing its story to those who study it. The interplay of ice and rock produces astonishing features. Subglacial mountains, hidden beneath kilometers of ice, rise as ancient sentinels, while valleys carved by glaciers hint at a watery past. The contrast between smoothed plains and jagged ridges demonstrates the dual nature of ice as both eroder and preserver. Sediments within glaciers reveal the paths of ancient rivers, the movement of glaciers, and the remnants of ecosystems buried for millions of years. Each feature, from the largest mountain to the smallest striation, contributes to a narrative of time, persistence, and change, a record of the continent's hidden history. There is a profound sense of connection in studying these frozen landscapes. To touch a rock smoothed by glaciers, to examine a fossil preserved in sediment, is to engage with processes that have operated over millions of years. Antarctica's hidden geology is a bridge across time, linking the present observer with past climates, ecosystems, and tectonic events. It is a reminder of the magnitude of geological forces and the endurance of life, even under conditions that would seem inhospitable to most species. Each discovery is both scientific and poetic, illuminating the intricate choreography of ice, rock, and life. Modern exploration has expanded our understanding of this hidden world. Ice-penetrating radar, seismic surveys, and satellite imaging reveal subglacial valleys, mountains, and lakes, exposing the complexity of Antarctica's bedrock. Drilled cores recover rock, sediment, and fossil material, allowing detailed reconstruction of past climates, glacial movement, and ecosystems. These technologies transform a frozen, forbidding landscape into a readable archive, where ice, rock, and sediment chronicle a continent's evolution across geological time. Antarctica's hidden geology is thus both a treasure trove of knowledge and a testament to the power of natural forces. And so, beneath the blinding white of Antarctica, ice and geology coexist in a delicate, relentless dance. Glaciers carve, erode, and transport. Volcanic activity reshapes and disturbs. Sediments preserve fragments of life and rock. The continent's hidden geology is a dynamic archive, recording climate, ecosystems, and planetary processes over millions of years. Every striation, moraine, and fossil fragment is a message from a world both alien and familiar, a reminder that beneath the ice lies a narrative of change, endurance, and wonder. Antarctica is not merely a frozen wasteland. It is a living testament to the power of ice and the memory of the Earth itself. The hidden geology of Antarctica is a story written in ice, rock, and time, a narrative of forces so immense that they dwarf human comprehension. Beneath kilometers of frozen surface lie mountains carved by glaciers, valleys smoothed by relentless movement, and sediment layers preserving traces of life from a temperate past. Each formation, from the jagged peaks that pierce the ice to the subglacial basins silently holding ancient sediments, is a record of a continent in constant transformation, shaped by erosion, deposition, and tectonic shifts over hundreds of millions of years. Glacial movement is both slow and unstoppable. Ice sheets advance and retreat, grinding rock beneath them, transporting debris across vast distances and reshaping landscapes with patient, inexorable force. The bedrock bears witness to this tireless work. Polished surfaces gleam under inspection. Striations trace the flow of ice, and moraines mark the limits of ancient glaciers. Embedded within these glacial deposits are fossils and sediments, frozen records of ecosystems that once thrived before the continent's freezing transformation. Antarctica's glaciers are simultaneously destroyers and preservers, sculpting the land while safeguarding the memory of life long past. Subglacial volcanoes punctuate this frozen landscape, leaving layers of ash and lava that tell stories of fire beneath ice. Heat from volcanic activity melts the overlying ice, creating subglacial lakes and channels that flow unseen, carving hidden valleys beneath kilometers of frozen surface. Fossils discovered in these volcanic deposits reveal ecosystems that endured despite catastrophic events, highlighting the resilience of life under extreme conditions. In Antarctica, fire and ice coexist in a delicate, dynamic balance, shaping a hidden geology that is at once volatile and enduring, a testament to the continent's complex and extraordinary history. Sediments carried and deposited by glaciers are invaluable archives. Each moraine, till layer, and embedded rock fragment reveals the direction and extent of glacial flow, the origin of transported materials, and the environmental conditions that existed before the ice's advance. Fossilized plant remains preserved within these sediments capture snapshots of ancient ecosystems, from lush forests to wetlands, providing insight into the continent's climate and biology long before it became a frozen desert. Antarctica's hidden geology thus serves as a living archive, recording the interactions of ice, rock, and life across deep time. Erosion has sculpted the continent into a landscape of contrasts. Smooth plains lie alongside jagged ridges, subglacial valleys hide beneath ice sheets, and moraines rise like monuments to the relentless passage of glaciers. Even the smallest features, striations, polished surfaces, or fragmented rock tell stories of immense forces at work. Fossils embedded in these layers connect the physical landscape with the biological history of the continent, revealing how climate, ice, and erosion have interacted to shape not just the geology, but the very ecosystems that once existed there. Antarctica's hidden geology is therefore both dynamic and layered, a multidimensional record of the planet's history. There is a profound sense of awe in contemplating this hidden world. Beneath the white barren surface lies a continent alive with memory. Mountains that remember tectonic collisions, valleys that recall rivers long gone, and sediments that preserve the whisper of forests and wetlands. Each discovery, a polished rock face, a buried valley, a fossilized leaf, is a connection to a deep past, offering insight into processes that operated over millions of years. Antarctica's hidden geology is a bridge across time, linking modern explorers with the continent's ancient climate, life, and landscapes. Technology has unveiled much of this secret world. Ice-penetrating radar, seismic mapping, and satellite imagery reveal subglacial features that were once invisible, while drilled cores provide tangible evidence of sediments, fossils, and volcanic deposits. Together, these tools allow scientists to reconstruct the complex interplay of erosion, deposition, and ice movement, providing a detailed picture of Antarctica's evolution. The hidden geology emerges as a palimpsest of time, a record of climate, tectonics, and life written across millions of years, awaiting those patient enough to interpret its stories. The narrative of Antarctica's hidden geology is not merely about rocks and ice. It is a chronicle of life, climate, and endurance. Fossils trapped within glacial sediments recall the temperate forests that once thrived, the rivers that carved valleys, and the wetlands that nurtured diverse ecosystems. Erosion and deposition shaped the land while simultaneously preserving the past, creating a frozen archive where geology and biology intertwine. Every striation, moraine, and sediment layer is a page in this story, revealing the magnitude of natural forces and the resilience of life in the face of relentless change. As sunlight glints across the endless ice, the hidden geology of Antarctica stands as a monument to both time and transformation. Glaciers carve and polish, volcanic activity reshapes and disturbs, and sediments preserve the memory of ecosystems long vanished. Antarctica is more than a frozen wasteland. It is a repository of geological and biological history, a continent where ice, rock, and life converge to create a dynamic, enduring archive. Each feature, each fossil, each layer of sediment is a testament to the interplay of forces that have shaped the southernmost land on Earth, patiently recorded beneath kilometers of ice. And so, Chapter 4 concludes with the understanding that Antarctica's hidden geology is not merely a backdrop to history, but an active storyteller. Glaciers grind and transport, volcanic activity disrupts and preserves, and sediments capture the memory of life and landscape. This frozen archive offers a window into the continent's past climates, ecosystems, and tectonic history, bridging millions of years of Earth's evolution. Beneath the white surface lies a narrative of endurance, transformation, and wonder. A story waiting to be uncovered by those who seek to listen to the silent language of ice and rock.